we felt a lot of the talks in the community were focused on Android, but with the increased demand for back-end use cases, we wanted to provide a platform and community to share knowledge. Kotlin for backend continues to grow. More and more of our clients across multiple industries are making the switch from Java, but also non-JVM languages as well. So it's really building momentum now. Today, we're excited to be joined by Anthony Accioli. He's given several technical talks in the past, and he's highly respected in the community and actually in the top 2% of Stack Overflow users because of his contributions. And today he's going to be walking through some interesting aspects of Kotlin with us, including technical demos. We want to keep it as interactive as possible, so do please add questions into the chat box. I'll keep an eye out and then sort of interject at a good time without stopping Anthony in his flow too much. So that's enough for me. Over to you, Anthony.
Hello, folks. Good evening. Let me share my screen. Can everybody see my slides, like thumbs up or something like that, so that I can actually see? Okay, good stuff. So Ben Dale had a nice introduction about me. I actually tried something a little bit too ambitious plan for this talk. So I was going to talk about 2 extra subjects related to generics, but I have plenty of slides and demos already. So the good news is there is going to be a second part. The bad news is we're looking at 2 less subjects today. So my name is Anthony. Before we even start, everything that I'm going to say here, it's on the Kotlin docs. Here's the link. Thank you for coming to my TED talk. That's all that you need to know. My name is Anthony, as Ben said. Now we're going to talk half an hour about me. I'm joking. So yeah, Ben Dale met me and that's why I'm here. I have my own company now. It's called 7RTC. So I don't have to put a disclaimer like usual, which is great. And I can call myself software engineer, no fancy titles, but I have plenty of those like VP at JP Morgan, principal engineer, blah, 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 blah. Let's start with the most important thing. I'm not a Kotlin developer by any means. Just after matching Ben Dale, I passed a technical interview for Kotlin, Kotlin position. And then I passed another technical interview for a Kotlin position, and then another. And right now I'm working with Kotlin. Yeah, trust me. I'm still not a Kotlin developer. If you want to be a non-Kotlin developer like me, here's what I did to learn a little bit. There's this nice Kotlin action book. Actually, the second version is already in an early version. It's due to be released next year, but the first version is good enough. There is also several courses on Coursera. I took an official one by JetBrains, and it gave me the very basics of the language. It was a very well done course. Despite not being so much of a Kotlin developer, I'm a Java developer, kind of. And I also wrote a lot of Scala code. As everyone knows, I'll have to put a disclaimer just for people that don't understand the irony here. Anton is the main evangelizer of Kotlin, and Andrei is the designer of the language, okay? And that's an actual stadium, and he did this presentation and he used these slides. The idea was not criticizing Kotlin by any means, it's just basically noticing from which language Kotlin were inspired and what they took from each language. So if you are a Scala developer and you want to get a trigger, you can look at his slides. At some point, he says that Scala looks like ASCII art. I was extremely offended. Please tell me more. Anton's channel is also a very good source for everything Kotlin, and I definitely recommend it to keep up to date. Okay, let's talk about Kotlin. Now, let's talk about Java first. So that I don't speak for 45 minutes in a row, I want some interaction here. How would you guys implement a is-palindrome method in Java? Can anyone chime in with some ideas? Someone, please. Any ideas are fine. No? Okay. 5 seconds. 5, 4, 3, 2, 1. Okay, so how would I implement an is-palindrome method in Java? I would reverse the string, right? And compare the reverse with the string itself, okay? The problem is you can't really get this nice race car syntax into a method. First, because, well, you can't have standalone functions in Java. You have to wrap it with a class. You have those static methods. If you don't want anyone to initialize the class according to Java block effective Java, you also need a private constructor that throws an exception. Okay, so that's a lot of initial boilerplate. You can use something like Project Lombok's utility class to make it a little bit more readable, but still, there are things that are right. I mean, a string should be immutable, so we can't just keep adding a method to a string, new functionality. There's a reason why a string is immutable. But a typical Java project will have those utility classes all over the place, right? The code grows, it becomes something without context. And it ends up producing some abominations. For instance, common length string util classes that does basically string manipulation things just like I shown you, has about 10,000 lines of code with those utility classes around string, right? This is not great. I think that everyone agrees. And I should go back to my slides. So, extension functions. Or actually, let's talk about functions in Kotlin first. So the first good thing that you know is, well, Kotlin already have a reversed method in the standard library, and equals is just an override to dot equals in Java. So two of the things that newbies kind of don't like fall into traps with Java are over. But more important than that, functions in Kotlin can be top level, which means that I can just create a file and paste that function and reference it from anywhere that I want. Actually, I don't need brackets. I can remove the brackets, and when I have just a simple expression like this, Kotlin will infer that this is a function. I can even do more. It's clear that a function that compares two things will always return a Boolean, right? So I don't need to give it a type. I can just omit it, and Kotlin will infer the return type. It's nice, it's terse, is a very good and expressive language. But we can do better. Remember, what we wanted to do is to call isPalindrome or reversed or whatever methods that we want directly on the string. And that is very simple in Kotlin. So I can create a function that will reference a string. So isPalindrome is an extension function of a string. Wasn't like strings immutable? Yes, strings in Kotlin are the same strings in Java. And I can show you how this works. So the IntelliJ IDE has a really nice functionality that lets me decompile classes. So let me just come here. This is just a strings.kt file. It has this single function. And this is how things look at a bytecode level, but let's decompile this and see what Kotlin is actually generating for the Java virtual machine. So it's generating pretty much what I was doing with Java code. Is generating a function class with a utility method, which is static. And there is some Kotlin magic here to check equals, etc., but it's basically the same code as before. And you can use it from your Java code. So you could, in Kotlin, you can call the method directly on a string. From Java, you can call the method strings.kt.isPalindrome, and it will work. More than that, the strings.kt is just a default. It's basically getting the name of my file and appending it like this. But you can customize the generated Java code with this file JVM name annotation. Give whatever name you want. So if on the Java side, you want this class to be called string utils, just like you would in regular Java, you can do it, and Kotlin will generate a Kotlin string utils class.
Anthony, sorry to jump in. Svetlana's just asked if you could show the code only, I assume to make it easier to read in IntelliJ.
So let me do something. Let me zoom in. Is it readable?
Yeah.
Okay. So, and let's go back to the Java version. And this is what Java has generated. Static method on a static util class, doing exactly the same thing as we were doing before in Java. All good? Any questions so far? Okay. Then let's move on. So that's not the only good thing that Kotlin can do with functions. So another interesting construct and something that I always miss in Java, we can argue that it's kind of a code smell, but sometimes you need to return two things from a function. So let's say that you receive a string and you want to return the first and the last character of a string, right? There is many different ways to implement this in Java. So you can return an array with 2 characters and construct it as you go. You can create a list with the first and the last character. You can create a map with the character. If I think that this no longer works on the latest version of Java, but on Java 9 and I think 10 as well, you had this JavaFX util pair class that you could use, but then again, like JavaFX class, yeah, shouldn't do it, right? The old school way that I used to do this kind of thing, which is not that clean as well, is map entry could be used as a kind of a pair. So you could just build a map entry from character to character, and that would work. The clean but more bureaucratic way to do it is to create our own class. So first and last class, result class, whatever you want. But then again, you're going to have to generate a constructor, getters and setters, like string, comparison, several other things just to comply with Java boilerplate code. You could, of course, use Project Lombok again to generate most of this for you. Or you could use an external library that has pairs. So Java tuples, Vaver, I don't know how to pronounce this, but I think that's how it is. But then again, if you are on the latest version of Java, they introduce records, which is very similar to something that we already had in Kotlin. And a record lets you declare your own type in like one line of code if you don't count the brackets, right? So this record, first and last, will create like the getters and setters and everything that you need in the, sorry, only getters because this is immutable, right? So yeah, one way to do it in Java would be to implement a static method again inside of your string utils class that we don't want to have, and retrieve the first character and the last character. So this is how it would look in Java. And we can test Java code from Kotlin. And there's where the things in Kotlin start to shine. I can receive the first and last and run this unit test. Behind the scenes, start with and B. Okay, it's unresolved because I run the wrong test. That's the reason. Demo gods. Let's comment all of this for now. And here we go. So we're using a Java record from inside Kotlin. And I'm using the scope function that we're going to get to basically retrieve first and last and see that the first lettering behind the scenes is B and the last lettering behind the scenes is S, right? Records are a nice solution. But then again, maybe the array of 2 characters would be less of a trouble. So we've done all of this, and yeah, in the end, we're creating a separate class and using heap memory, and yeah, not so good. So Kotlin has another interesting feature. First thing is, I said that records are inspired by something that already existed in Kotlin. I think that this was mentioned in a previous talk, so I'm not going out of my way to explain. But Kotlin has data classes. Data classes are similar to records, although they are more powerful. You can use values for immutable variables. You can have vars for mutable things, and it generates several utility methods for us. So not only toString equals hash code, etc., but also some extra methods that will do some magic that we're about to see. So if you want to do the same way as I did in Java, you can declare a class and you can return it as a wrapper with the values that you need. As you can see, Kotlin already has first and last methods on the string. Since this is an extension method, I have access to this dot first and this dot last inside of the extension function body, which I don't need. So actually, first and last are methods, are extension functions in Kotlin in a string itself that are being calling from another extension function. So this is how it's working behind the scenes. I'll show you the compile code in a minute. But Java can do, Kotlin can do what Java does with a better syntax. I don't need to keep this first and last wrapper around. I can destructure first and last into two variables. So input first and last is returning this data class. And the data class is being destructured into two components, first and last. Okay. So, well, before I show you how it's doing this under the hood, there is also some small things that are very convenient in Kotlin. So you can have method and function names with spaces. This is common in Kotlin test code, is part of Kotlin code conventions to begin with. So, and you probably repaired on this should be, first should be B, first, last should be S. This should be is actually a method like any other, but is annotated with this infix keyword, which makes it an infix notation. So it kind of looks very clean, you know, you don't need dots or parentheses or anything like that. And I found out that especially if your company is looking for a way to do something with Kotlin, but it's very like Java oriented. One idea is to keep like your services in Java and start with Kotlin tests. So that's how I introduced Scala in a previous company, and I also kind of starting with tests on the company that I'm at right now. So yeah, that's a hint for people wanting to do something with Kotlin. So behind the scenes, how this is working is, let's go to my demo again. And if we look at the string class, I will uncomment this guy over here. And let's do the same trick again. Let's let Kotlin decompile the code to Java. And what has been generated is first a Java class with getters, just like regular ones in Java, and a constructor. And it has also generated methods called component1 and component2. You could have more than two. You could have component n. So if you're dealing with a list and I don't know, we want an easy way to retrieve the 20 or so first elements of a list, you could implement component 1, 2, 3, 4, 4, 5 until 20, right? There's other utilities since first and last are immutable. You can also like have methods to copy the content. You have toString, hash code, equals, everything required by Java, right? So behind the scenes, when you, let's now uncomment this. When you have something like this test method over here, doing some destructuring, when the Kotlin sees something like this, it will actually bind the components by index. So the first one will be component 1, the second will be component 2, and so on. This is all type safe. Kotlin knows that this is a character because it's calling a component method that is returning a character. So, sure. Okay, so this works. Of course, like you don't need Kotlin to auto-generate stuff for you. You could just use a regular class and implement your own component methods. And Kotlin has a pair, built-in pair. So interesting thing to point out. Since I'm not reference first and last the class, the data class, anywhere in the test code, I will just comment this and uncomment a version which is using a pair, right? So I'm no longer returning first and last, I'm returning a pair. And I can run the same test suite here. And since first and last was not referenced directly anywhere, I'm replacing first and last data class with a pair with no compilation errors. Demo gods, please help me. And yes, so I can replace it. It's not referenced anywhere. It just works. So this is one of the advantages of type inference and this sort of constructor. Back like in the days, a long time ago, Kotlin has pairs, it has triples. It used to have tuples, just like Scala. So you could have like sets of more than 3 elements to return in the API. But then again, this leads to some abuse, right? If you have more than 3 things, you probably want a class to name things correctly. So yes, use data classes when you need more than 3 elements. Another interesting thing about this structuring declarations is that you can use the underscore operator to discard any of the parts that you don't need. So if I only need the first letter of a name and I don't need the last one, I can just place an underscore and it will ignore the last character. This can be very useful when you're using collections and lambdas. So let me go back to the demo. And that's the one. Okay. So let's say that I have a map with some names, Michael Jordan, Franz Ferdinand, etc. And I want to get the initials of those people, right? 2 nice features here that I'm not explicitly mentioning on my slides. I have a function inside a function, and that's perfectly fine. And it has everything in scope in that function. I can have a function inside a function inside a function. So yes, functions are first-class citizens in Kotlin. And Kotlin also has a pretty nice feature that I hope that we get in Java at some stage called string interpolation. So this syntax over here is replacing this whole thing is basically retrieving the first character of the first name, then appending this to a dot, and then replace the first character of the last name, right? I can combine this with a lambda function and map Michael Jordan and Franz Ferdinand to a list with their initials. So to MJ and FF. And since we're going functional, there are many things that work very well with collections and with lambda functions. And it's funny because, you know, there's a scale of very experimental languages like Haskell, which like pure immutable and very functional, to languages like Java that are trying to adopt functional style programming without breaking backwards compatibility. And as someone that spent some time with Kotlin and Scala, we've kind of we don't miss the things that we don't know, basically. So there are several functional idioms that are very, very nice to work with. They are high level and they are very expressive, right? But when all that you know is, I don't know, strings, you don't miss them in Java. But when you're using Kotlin or Scala or Haskell or any of those functional languages, and you know how to use those tools, you basically start coding and thinking into a declarative way. So it'll kind of like SQL. Instead of describing what to do, you tell the language, instead of describing how to do something, you tell the language what you wanted to do, right? And you need some nice way to bind things together, and that's scope functions in Kotlin. So scope functions is just a set of lambdas. It's basically a set of utilities and extension functions that works on lambdas and allows you to execute like a block of code against a specific object. And they are there just to let you bind things together nicely. They are very idiomatic. There is a typo here. They are prone to abuse. So yeah, there is this table that I just copy and pasted from Kotlin documentation. And it describes the many flavors of scope functions that Kotlin lets you play with. So you have let, run, with, apply, and also. And they all operate into objects and let you chain things together. So when people first look at more idiomatic Kotlin code, it can look a little bit scary because you are going to see like a cascade of code like this. And if we remove like a little bit from the picture, like our preconceptions and focus on one code at a time, it is very declarative. So it looks complicated, but at least to me, after you adjust to it, it's not. It's easier to express things this way. So let's say that I have a Michael Jordan person. This is a data class. And I want to do a bunch of operations with Michael Jordan, right? So one thing that I could do is I want to verify that I initialized Michael Jordan with the right parameters, right? And I could do something with Michael Jordan here. I could, I don't know, have it play basketball. This let, basically just like the JavaScript let keywords, it lets me run this P block referring to the person that I'm pointing at and do everything that I want inside this scope. And I'm actually using it kind of wrong here because let, it returns a lambda result. And in this case, I'm kind of returning the person itself. So the last line is the same function that I have here. So probably I could pick another one of those functions. Maybe I'll ask this question after we're done here. Apply can be great when you need to basically set and configure an object. So here I found out that Michael Jordan is actually 59 years old and not 58. But a more realistic case would be I could be building a map of configurations in Spring. I could be, I don't know, injecting parameters somehow. So apply is a good function when you need to basically mutate and configure the object, right? Apply takes the object itself as this instead of a reference like let. So I don't need to call p dot age plus equals 1 because this is in scope and this refers to person. Person is Michael Jackson, right? In a similar spirit as let, but this is one that really shouldn't be abused, is one called also. And the idea of also is when it should, the official recommendation is you should use also to log stuff, log things, you know. People tend to use also to do mutable operations and break the flow. Don't. Also is meant just to have like some quick side effect, use some IO, send some metric, print a log statement, do something like this. Also, just like let, receives the referring object as a parameter. And the difference with let is instead of returning the last line, it actually always returns the object. So you can see that I'm doing some operation to check here. This returns unit, which is the same as void in Java, means nothing. But also completely ignores this. It's just returning the person. So it's different than let because it returns the context object. Finally, run is kind of a mix. Run uses the this scope instead of reference things as parameter. And it does take the lambda result. So in this case, I'm using my initial function that I created on that other example, and saying that Michael Jordan, basically returning a string, saying that Michael Jordan is 59 years old, right? Since this is the last block of code in my whole chain, the result of this whole chain will be this string over here. So result is Michael Jackson is 59 years old. And just because I needed a way to demonstrate the last method, I'm also abusing this again. I could call the result should be Michael Jackson. Michael Jackson is 59 years old. But let's say that I wanted to verify several things about this string. Let's say that I wanted to verify not only that the string is Michael Jackson is 59 years old, but I also want to verify that this string only has 2 digits, and I would want to verify the number of characters in the string. So the with function is using Kotlin idiomatically exactly for this purpose. So it receives the object reference as this in scope, and it returns a lambda result. So in this case, it would return unit. So this doesn't return anything. So with is used in several occasions. For instance, Java has try with resources. You can do something very similar in Kotlin using this kind of idiom. So you can open a buffer reader and have it auto close with the with block. So like Python people will be very familiar with this kind of idiom as well. So we are almost out of time, and I want to leave some space for questions. So yeah, let's jump to the end. I will publish the slides probably during the weekend. Also the demo code, and yeah, feel free to ask me anything.
Yeah, we'll be sharing the recording as well if you wanted to come back to it for people that have jumped in late or what have you as well. But yeah, any questions, please fire them in the chat.
People like the presentation.
All questions answered. Cool. And so, are you happy to, if people sort of think of stuff or questions afterwards? Oh, hang on, here we go. There is a question.
Okay.
Which companies have you interviewed for Kotlin dev positions? That might be a recruiter trying to steal clients from us. No, it's not. It's Svetlana. So feel free to answer if you'd like to. But
okay. So yeah. So first question is should question mark let be used instead of if not no? So that's an interesting question. It touches into 2 different aspects of Kotlin. So this is a great use for let. Let's say that person here could be no, right? So let's make this a newable type, which Kotlin won't let me. And I know. Let's do this. So there was I think the first Kotlin source talk was about newable types. So Kotlin has a distinction between what is nullable and what is not null. So in this case, let's say that I'm working with Java and this person could be null, right? So in Java, you would get a null pointer exception because the type is not being checked at all. Kotlin has this nice feature called the Elvis operator, and it's called Elvis operator exactly because it looks like Elvis' hair sideways and his little eyes. And that's one way to get rid of null statements, is to basically use the Elvis operator. Another way is, let's say that I don't have a good default when like I have to work with nullables here. So one of the purposes of let is I could, of course, come here and say if person is not null, then do something. But I can use something more idiomatic in Kotlin and use the here. I could just do this. So basically, what this question mark does here in combination with left is, if person is null, don't do anything. Otherwise, execute what is in that block. So yes, that's an idiomatic way to skip through nulls in a chain of calls like this. So let me return to exactly how things were before. I hope this answered your question. If not, tell me again. Actually, Ben, do you want to read the other questions to me? I think you're muted.
Yeah, sorry, the chat was just getting a bit clogged up. Tiago's put the main difference for him with Kotlin is, well, between Kotlin and Java is non-blocking and Kotlin's coroutine system, which makes a difference. I don't know if you have any thoughts or comments on that, Anthony?
So yeah, so Kotlin, there is a very interesting thing there. Even before coroutines was a thing and suspending functions and like all of the channels and all of the good things that come with it in Kotlin's main library, there was a library in Kotlin, which was called Quasar. And it was a very nice implementation of fibers and actors and several great concurrency models. But then again, since it didn't have, there is an helicopter just over here creating chaos. Just 1 second. So since it was just a library, it didn't have access to JVM internals. Quasar was ahead of its time, but it wasn't like the best implementation and it kind of died. But the creator of Quasar became the spec lead to the user group of the project Loom in Java. So now like Java is implementing fibers and some of the goodness that was in Kotlin, I don't know, 5-6 years ago. Meanwhile, Kotlin has implemented a lot of ideas from languages like Go channels, and I don't know, Erlang. So yeah, in a way, Kotlin is innovative ground for a lot of like concurrence models that I wouldn't say that they are new for the JVM, because Scala was doing this quite a while ago as well, but they are certainly it's certainly ahead of Java in terms of concurrency and distributed systems.
Joe has asked, what's your preferred approach to error handling in Kotlin?
So that's the kind of thing that don't have like I don't have a direct answer to that. In a way, I believe that teams have to have their own coding conventions. You know, I have no problem with if I'm working with like a simpler, say, Spring Boot project done in Kotlin that is closer to Java, and I'm working with several Java developers that are just converted to Kotlin, I will probably write like nicer Java in Kotlin, meaning that I will throw exceptions and I will follow very standard object-oriented practices, right? If I'm working with developers that come from a Scala background and they are using with functional dialects like either and I don't know, they know what monoids are, what monads are, and they think in more of a functional way of doing things. So there are libraries like Arrow, which like has types like either and several other goodies around it. So if I'm writing code on my own, I'll probably use a more functional style, but in practice, at least for work, I'm pretty much like following standard Java practices in terms of exceptions. I don't know if this answers your question, but yeah.
We'll do one more if that's okay, Anthony, and this is from Joseph around the performance of Kotlin and how that compares to Java. Would you agree Kotlin's main strength is less code and boilerplate? And if that is not its main objective, stick with Java. He is playing devil's advocate there, but interested to get your thoughts on that.
So, two things. The Kotlin compiler is pretty good. I mean, like the team behind it was JetBrains, and they know Java internals in and out because they make the IDE. So Kotlin compiler is pretty good at optimizing the instructions, and it works very well in generating bytecode that can be properly optimized by the Git compiler and stack replacement. So basically, well-written Kotlin can be as performatic as Java, right? Depending on the idiom that you choose, things are more expensive. So if you're going fully using immutable collections and map all over the place, and you're not using sequences, you are going to create a lot of trash and garbage collector will hit. So the performance of Kotlin, it's not bad. The strengths of Kotlin, there are several, in my opinion. First is the tooling. I'm using IntelliJ. Almost everyone, I'm pretty old school. I used to use NetBeans and Eclipse back in the day, but JetBrains has dominated, and it's been almost 10 years since I used another IDE, and I can copy and paste Java code and transform it in Kotlin and vice versa. And I have great insights, and the IDE will teach you functionality from Kotlin. So it will teach you how to use a type, or if I use something wrong, I have all of these analysis helping me. So that's great. The second thing is, as much as I love Scala, there is a bad side to it. I'm not calling it ASCII art like the designer of Kotlin, but since it is an experimental language, it's not so much about backwards compatibility. Things change very fast, and it's easy to write unreadable Scala, while of course you can write unreadable Kotlin, but Kotlin has a nice syntax. It appeals to like a more pragmatic developer that wants to get things done. The other thing that we have to say is I'm a backend developer, but like JetBrains did something massive when like Google adopted it. So they are on mobile. You have Kotlin native that also can be used for like and executables like without the JVM. You have Kotlin JavaScript binds that you can use to generate JavaScript code for either to run on Node.js or even to run on the browser front end. So kind of Kotlin is like getting popular into multiple fronts. So Java developers like me are creating Spring Boot applications or Micronaut applications or Quarkus application, and they are migrating to Kotlin as a better Java. Mobile folks are using Kotlin. JavaScript folks can use it. So there's industry support. It is solving a pragmatic problem, and it's basically everywhere. So that would be the main strengths of Kotlin, in my view.
Perfect. But yeah, I guess we'll wrap things up. Hopefully there's still some sun outside for everyone to get onto. I think I'm going to get a beer myself. So really appreciate everyone's time. I'm sure Anthony will be happy to answer any questions. If you either reach out to me and I can speak to him, or I'm sure he'll be happy to connect on LinkedIn and what have you. Any sort of ideas for future talks or speakers or anything like that, we'd love to hear from you as well. But yeah, thanks very much everyone for joining, and thank you very, very much, Anthony, for an excellent talk.
Cheers out. And if one of the ideas is generics and covariance in Kotlin, let Ben know and I'll come back to talk about this.
We'll definitely have you back. Thanks very much. Take care, everyone.
Cheers. Bye-bye.